Somewhere in this grass is one of Florida's largest predators. You probably can't see it. That's the point. Burmese pythons have spent more than 2 decades spreading through South Florida, swallowing native animals whole and vanishing into terrain where even trained researchers with radio equipment can spend days tracking a single snake. Thousands have been caught. How many remain is much harder to answer. Burmese pythons are native to South and Southeast Asia, where they move through jungles, grasslands, and river valleys, hunting mammals and birds in warm, wet terrain. They have no business being in the Florida Everglades, but by the late 1970s, they were already there. The exotic pet trade brought them in. Burmese pythons were cheap to buy as hatchlings and for a while popular in the American reptile market. The problem is that a hatchling python doesn't stay small. Within a few years, an owner who bought a 2-foot snake can be looking after something 12 feet long and openly hostile to the size of tank they can afford. Some of those owners simply let their snakes go. For decades, the dominant explanation for Florida's python population was Hurricane Andrew. In 1992, the storm tore through South Dade County and destroyed several facilities that housed exotic animals, pythons among them. But that's not the whole story. Florida wildlife officials say pythons were already being detected in the Everglades as early as 1979, more than a decade before Andrew made landfall. A 2011 scientific review concluded the simplest explanation is that a small number of individual snakes were released sometime before the mid-1980s, with the population slowly building through the 90s before growing sharply after that. Andrew may have added more snakes to a population that was already establishing itself. It probably didn't start it alone. Either way, a handful of escaped pets is not the same thing as an invasion. Pythons that escape and die don't build a population. Pythons that survive find each other and reproduce do. So the real question isn't just how they got in, it's why they didn't disappear. South Florida turned out to be almost perfectly suited to a giant Asian constrictor. The climate is warm and wet nearly year-round, similar enough to the python's native range that the snakes barely had to adjust. The Everglades and the surrounding wetlands offer an enormous, largely unbroken stretch of marsh, sawgrass, and hardwood hammock, connected mile after mile with almost no natural barrier to stop an animal that swims as easily as it crawls. Prey wasn't a problem either. Raccoons, rabbits, wading birds, and deer were already abundant across the region. What none of them had was any history with a predator like this one. The Everglades hadn't supported a large constrictor snake in millions of years, and Burmese pythons introduced a kind of predation pressure the ecosystem simply hadn't dealt with before. That combination, ideal climate, enormous habitat, abundant prey, should have made pythons easy to track down once wildlife officials realized what was happening. It didn't. A python well over 10 feet long sounds like something you couldn't miss. In the Everglades, you can walk within a few feet of one and never know it's there. Burmese python skin is patterned in dark, irregular blotches that blend almost perfectly into shadowed sawgrass and leaf litter. The snakes are largely inactive during the day, and much of their movement happens at night or underwater, where a human observer has essentially no chance of spotting them. Researchers who study how often pythons are actually detected during field surveys describe the odds as extremely low, even for experienced searchers moving directly through known python habitat. In dense marsh, a large python can be lying within arm's reach of a survey line and go completely undetected. This is the part of the story that makes Florida's python problem different from most invasive species. You can't manage what you can't reliably find, and Burmese pythons, whether by accident of evolution or advantage in a new environment, turned out to be extraordinarily good at not being found. While researchers were still working out how to detect the snakes, the mammals were already disappearing. A study published in 2012 compared nighttime road survey data collected inside Everglades National Park before and after the python population took hold. Before 2000, raccoons and opossums were among the most commonly sighted mammals along the park's roads. Between 2003 and 2011, raccoon sightings on those same road surveys had dropped by more than 99%. Opossum sightings were down almost as much. Bobcat sightings had fallen by roughly 90%. Marsh rabbits and foxes, once regularly recorded, weren't detected at all. The researchers were careful about how they framed this. These are declines in road survey sightings, not a direct census of the actual population, and a decline that coincides with python expansion isn't automatic proof of a single cause. But the pattern held specifically in areas where pythons had been established the longest, and it was consistently absent in areas the snakes hadn't yet reached. That kind of spatial pattern is difficult to explain any other way. Follow-up research, including studies that tracked radio-collared marsh rabbits released into python territory, later found that pythons were responsible for the large majority of the rabbits that died within the first year. It's not that Burmese pythons have destroyed the Everglades. The ecosystem is far more complicated than any single predator, but the evidence linking pythons to a serious decline in native mammal sightings is about as strong as this kind of field research gets. Part of the reason the impact runs so wide is that Burmese pythons aren't picky. A long-term study examining the stomach contents of pythons, collected across South Florida over 2 decades, identified dozens of different prey species, birds, mammals, and reptiles, wading birds, squirrels, white-tailed deer, even other snakes, and in a handful of documented cases, something considerably larger, American alligators. Researchers have recovered alligator remains from python stomachs on more than one occasion, evidence that a large enough python can, and sometimes does, take on one of the Everglades' other apex predators. It isn't routine, and adult alligators aren't a standard part of the python's diet. But it's documented, and it says something about what these snakes are physically capable of. Alligators return the favor. Cases exist of pythons found inside alligators too. In the Everglades, the two predators now occasionally compete, and sometimes kill each other, in a relationship nobody planned for. Knowing what pythons eat doesn't solve the problem in front of Florida's wildlife agencies. How do you remove an animal you can barely see? The state has tried several approaches at once. The Florida Fish and Wildlife Conservation Commission runs a network of contracted professional hunters who search public lands for pythons year-round. Since the early 2000s, thousands of pythons have been formally removed from the state and reported. Then there's the Florida Python Challenge, an annual public competition that invites hunters from across the country to search for pythons on designated public lands over 10 days, with cash prizes for the most snakes caught. Recent challenges have drawn close to 1,000 participants and removed several hundred pythons over the 10-day event, a record year among them. It's a real contribution, and it raises public awareness. But set against a population nobody can confidently size, a few hundred snakes in 10 days makes clear how much habitat and how many pythons remain completely out of reach. One of Florida's most fascinating removal strategies doesn't rely on hunters simply searching the landscape. It relies on the pythons themselves. Since 2013, the Conservancy of Southwest Florida has run a program built around a technique that sounds almost too clever to be real. Researchers surgically implant radio transmitters in male pythons and release them back into the wild. During the winter breeding season, these tagged males do exactly what a male python is driven to do: search for the largest, most reproductively active female they can find. Researchers call them scout snakes. The team tracks the tagged males by radio telemetry, following their signal into the field. When a male leads them to a breeding aggregation, sometimes several males clustered around one large female, the team can remove the group at once and take the female before she lays her eggs. One scout snake, working exactly as its own biology intends, can lead researchers to snakes no visual search would ever have found. Over more than a decade, The program has removed tens of thousands of pounds of python from a defined stretch of southwest Florida, including some of the largest females ever documented in the state. But scout snakes aren't a solution to the entire invasion. The technique works well in the specific area it's deployed, and it depends on a limited number of tagged males, careful year-round tracking, and a dedicated research team. It can meaningfully suppress reproduction in a defined zone. It cannot on its own cover the full range of a population spread across the greater Everglades ecosystem. Which brings the story back to the real question. Why can't Florida just eradicate the python? Researchers who reviewed decades of python control efforts have concluded that complete eradication from southern Florida is unlikely with current tools. Not simply difficult, unlikely given the terrain and the technology available right now. The habitat is enormous, much of it swamp and marsh that's difficult or impossible to search on foot. Detection rates remain extremely low, even for trained observers. The population has been reproducing for more than 2 decades, long enough to spread beyond the original invasion zone in the Everglades into surrounding areas of South Florida. And basic biological questions, how long individual pythons live in the wild, how often they successfully reproduce, how large the total population actually is, remain only partially answered. Because the same detection problem that makes hunting difficult also makes studying the species difficult. That's why researchers increasingly draw a distinction between control and eradication. Eradication means removing every single python. Control means reducing python numbers enough, in the areas that matter most, to give native wildlife a chance to hold on or recover. Every scout snake, every python caught during the challenge, every contractor removal doesn't end the invasion. But it does keep the pressure on a population that would otherwise expand unchecked. Florida knows the python is there. It knows what the snake has done to the Everglades mammal populations, and it has spent years building tools sophisticated enough to use the animal's own instincts against it. But controlling an invasive predator starts with finding it. And after more than 40 years in Florida, the Burmese python remains extraordinarily difficult to find. Current tools. Not simply difficult, unlikely, given the terrain and the technology available right now.